Let's discuss about bottom-up parsing. Bottom-up parsing, from the name itself, it is parsed from the bottom to reach the start symbol of a grammar. If a grammar is given and some of the productions are also given, then we will create a parse tree. Then based on that parse tree, we are passing from bottom to top in order to reach the start symbol of any grammar that is given. Okay, in the bottom up parsing technique, we are starting from the leaf nodes of any parse tree, leaf nodes, and then we are comparing every symbols with the production that is given, with the production of the grammar that is given. Then we are substituting that values in order to reach the start symbol, that is turning back to reach the start symbol. That is the purpose of a bottom up parsing. So in the bottom up parsing, first technique or first method technique to be used in order to perform bottom up parsing is shift reduce parsing. Shift reduce parsing means two actions are there, shift and reduce. So these two actions are the predominant actions to be performed in a shift reduce parsing. Then we will see in shift reduce parsing, it has two data structures. In shift reduce parsing, we use two data structures. The first one is stack and the second one is input buffer. Okay, and in the stack is used to store the symbols of the grammar. If a grammar is given with some of the productions, and the stack stores the symbols of the grammar. Okay, input buffer, as usual, input buffer is used to store the input string which is given in order to reach the start symbol, in order to the string to be passed. What is the string that is given in the question paper? That string is stored in the input buffer. Okay, there are the two data structures which is present in the shift reduce parsing. The first one is stack and the second one is input buffer. And also there are different actions that should be performed in a shift reduce parsing. The first one is shift reduce, accept and error. Four actions are there in a shift reduce parsing. The first one is shift, second one is reduce, third one is accept, fourth one is error. Shift means adding or pushing some of the symbols into the stack and comparing that symbol with the grammar, and such a type of comparison is being done in order to reduce or in order to reach this start symbol by substituting any one of the grammar symbols. We will make it clear by using an example. And the reduce, the same thing, the reduce is if there is t gives id, then id can be reduced by t. That is the reduce action. Will be clear by using an example. We'll make it clear. Okay, third one is accept. If the start symbol, the stack symbol is filled with, if all of the actions are performed, shift reduce actions are performed in order to reach the start symbol, then we will get an action such as accept. That is, it is reduced it is reduced to reach what the start symbol. That action is called accept. If there is any symmetrical error, because we cannot reduce any one of the symbols with any one of the production, we write in the action column as error. Example, and example grammar given is e gives e plus t bar t, t gives t star f bar f, f gives e, that means bracket, opening bracket e, closing bracket bar id, and the input stream that is given is id star id. Okay, in order to perform shift reduce parsing, you have to construct a table. In that table you have to include first column with stack, second one input buffer, third one the action to be performed. Okay, in this stack you have to add the beginning with a or begin the stack with a dollar indicates the bottom of the stack, and the input buffer is the input string. Whatever the input string is, just copy the input string as it is and just indicate a dollar symbol also along with the input stream in order to indicate the end of the string or the end of the input. Okay, then only then if we added this stack, if we filled the stack also input buffer, then we have to compare the element, whatever the element is there in this tag. You have to compare that element with the right hand side of the grammar which is given in the question. If they matches, or if that particular grammar given a particular another production, you have to substitute that with that. Okay, I will make it clear. Then just move to stack. There we have a dollar symbol. Compare that dollar symbol with the grammar. If you find anywhere the dollar symbol, you have to substitute that dollar with that particular production, or with that particular non-terminal, whatever it is. So unfortunately there is no dollar symbol in the right hand side of the production. Okay, so we have to shift the input string. So we have to scan the input string one by one, and we have to push the input, whatever the symbol, whatever the identifier, the star symbol, again identifier, into the stack. So first I add the id into the stack. So there will be dollar, then id. So that action should be added in the first row, or the first of the action. Okay, shifting the id to the stack, that shift is written in the action column. Then again in the second step is dollar id will be there. You have to fill the input buffer with the remaining input stream, that is star id dollar. Also we have to compare. Then after filling the input buffer, you have to compare the stack element with the input grammar. Then what is the stack element? It is the id. Compare or check for id. If id is present anywhere in the right hand side of the grammar, you have to substitute it. Check. Yes, f gives e bar id. So f has two production, open bracket e, close bracket, bar id. F gives id, f gives e. Okay, so we have to replace that id with the f, with af. Okay, so that action is written in the action column, the second action column. That what reduce by how it is reduced, f gives id. Okay, then again we come back. Again the third step, id is replaced with f. The input buffer is written same as above, and again we compare the stack with the elements with the right hand side of the grammar. Yes, find out. Yes, in the second production you have f, t gives f, t gives t star f. Two productions are there for t, so t gives f, so f can be reduced by t. Reduced by t gives f is the third action. മനസ്സിലായോ? Okay, f can be reduced by t gives f. Then then the next step is f is replaced with the t. You have to write the remaining string as it is. Then perform shift action. What it is shift? Compare any element t is there in the input grammar. Yes, t is there in the input grammar, that is e gives e plus t bar t. Either we can directly write e in this in the place of t. If you write e in the place of t, it will become what? It will become e. Then in the next step, if we write, for example, if we write e in this place of t, we have to, in the very next step, we have to compare that e, capital letter or the start symbol e, with the right hand side of the grammar. We wouldn't find any e in the right hand side of the grammar. So what we do, we totally will be, there will be stuck totally. So next action, what is to be performed? The shift action. Okay, so if it is that conflict, we can either reduce or shift. If we reduce it, it will become there occurs a conflict here. What conflict? That conflict or that type of conflict is called shift reduce conflict. Okay, or what we can do, just shift that star into the stack along with the dollar $t star. Okay, the stack is filled with a dollar T star. So what I have told is that if we replace T with E, we cannot find any production. In the very next step, we cannot find any production as E, which derives E, which reduce E itself. In the third production, it is bracket, open bracket, E, close bracket, not E alone. Okay, then we will get a totally error if we reduce T by E. If we perform shift action, then we can move for another, we will get another type of production as T gives T star F. Okay, so we perform shift here. That type of problem which arise is called a shift reduce conflict. You understand? Yes. Then we performed shift, that is shifting star with the T. Then again there is nothing with the T star. T star is incomplete here, so we again perform shift. So write a shift here. So T star, then shift means the next ID is pushed into the stack. The T star ID is the will be there in this stack. The input buffer is filled with only with a dollar. The other symbols are already pushed into the stack. Then T star ID. Then what is here? T star ID is not there, but ID we can reduce ID by F, that which we have already done in the previous session. Okay, this ID is replaced by F. Reduce, the action should be reduce F gives ID. Okay. Okay, and again we look for so we replace ID by F in the very next step, and fill the input buffer with a dollar. Again we look for this stack T star F. If there is any T star F in the right hand side of the production, yes, it is there in the second production, so we can replace T star F by T. So that action should be written in the action state, that is reduce T gives T star F. Okay. Okay, then in the next step, T star of is replaced by T, input buffer dollar. Then again we look for T. If there is any T in the right hand side of the production, yes, it is there. In the first production, E gives E plus D bar T. So T is reduced by E, and that action is written in the action state, reduce E gives T. Okay. Then yes, we got it. That is, the stack is filled with a dollar and the start symbol of the grammar which is given in the question, and the input buffer is also represent the end of the string. That means all the entire input string is scanned, and the action is in the action column. You have to write it as set. Okay. I will explain another example also. It will make you clear. So let's explain with another example. Another example of shift reduce parsing. In this example, the grammar given is S gives open bracket capital letter L close bracket bar A. L gives L comma S bar S. Okay, and the input string is open bracket A comma open bracket A comma A close bracket. I think you can clearly see it. And in order to perform the shift reduce parsing, you have to build a table for that, and in the first column should be a stack, second one input buffer, third one the action to be performed upon the stack. And I have already said the stack, the first element in the stack should be a dollar, and so we add a dollar in the first element as first element in this stack. Then the input buffer, whatever the input string which is given in the question, just copy that input string as it is in the input buffer. Also remember to add a dollar in order to indicate it is the end of the string. Okay, after copying the input string as it is in the input buffer, just give a dollar symbol also at the end of the string in order to represent it is the end. Okay. Okay, then what is the action to be performed? We have to compare the first, if we filled the stack column as well as input buffer column, you have to come back into the stack column and compare the element in the stack column with the grammar which is given in the question. So there is no dollar in the right hand side of the grammar, so we have to obviously give the action as shift. Okay, shift, just what is the first element in the input string, that is the open bracket. Shift that bracket into the stack. So in the stack there will be a dollar open bracket, and write the remaining stack without the open bracket in the input buffer. A comma a open bracket, a comma a close bracket dollar. Then if check for if there is any open bracket in the production, right hand side of the production, no. In the first production there is open bracket L close bracket, that is the production. S gives open bracket L close bracket, and then that production is A, not a single open bracket. Okay, so we cannot use it is. Then the next step is again a push. If we cannot find any similar elements from the stack and the grammar, you have to perform again a shift action, or you have to push the very next element into the stack. So A is pushed, so open bracket A. So compare and write the remaining remaining input string as it is in the input buffer. Compare open bracket A with the what? With the grammar, right hand side of the grammar. If there is any A or open bracket A, no open bracket A, only a single A is there, so we can reduce S gives A as S. The one production of capital letter S is S gives A, another production is S gives open bracket L close bracket. So A can be reduced by S gives A. Okay, you understand? So replace A by S. Okay, so in the next step, A is replaced by capital letter S, and write the remaining input buffer as it is. Then look for the you have to write, don't forget to write the action which is performed in the prior stage. Okay, and again we look for the stack. Open bracket is there, S is there. Open bracket no use, yes, capital letter S. In the second production of the grammar there is L gives S is there, so reduce by L gives S. Okay, so replace capital letter S by L in the next step. So S is replaced by capital letter L, and the remaining input string is given as it is. Remaining input string is written as it is. So again we look for the stack. There is L, no L is there, one L is there, but it is accompanied with a what? Open bracket and close bracket, and in the second production there L gives L comma S. It is a single production, not L alone. Okay, bar in the one side of the, if a production is there in the one side, it is given as a single production, not L alone, so we cannot write L. Okay, then shift is performed. What is the next element to be pushed into the stack? It is the comma, so push the comma into L. So again we compare the also don't forget to write which action is performed in the action column. Okay, then in the stack there is dollar open bracket L comma. Compare with the grammar. Nothing is similar with there, because L comma S is there. If L comma S is there, we can just reduce by L. So there is no L comma S, just L comma. So again we perform shift. Then what will happen? The open bracket is again pushed into the stack. We compare with the grammar. No use. Again we perform shift action. Every step, each time you perform the action, you have to write all the input buffer, all the input string as it is in the stack. If we push this, if the push one of the element into the stack, exclude that element and write the input buffer as it is. Don't skip any step, don't skip any input string. If we need to write again and again, it will reduce the mark. Okay, write as it in this step by step process. Then again a close opening bracket is there. So L comma opening bracket, again no similarities from the grammar. Again we perform a shift action. You have to write the shift action there. Then again what happened, A is again pushed into small letter A is the very next small letter A is pushed into the stack. Okay, L comma so what are the elements which is present in the stack? Dollar, open bracket, L comma open bracket A. Okay, so we cannot find, we are comparing the elements of the stack with the grammar. What is any similar grammar? Yes, a small letter A is there because S gives small letter A, one of the production of the first production. S gives bracket L bracket close, also S gives A. So A can be reduced. Reduce S gives A. A can be replaced by capital letter S. So in the place of A, in the next step, in the place of A, we write capital letter S. So again that row is again filled with the input buffer. Again we compare that stack with the grammar in order to conclude which action to be performed. So S is there, again S is there. We can reduce L gives S. In the place of capital, in the second production, in the place of S we can write L. Okay, remember that we need to get the starting symbol capital letter S alone in this stack. Okay, that is our aim. So L is replaced with S. Sorry, S is replaced with L. We again look for the grammar. Which are the action to be performed? No, there is nothing similarities with the grammar which is given. So we do what? So we do what? Here this is the step. So we again shift. Shift means again the very next symbol in the input buffer is comma. We shift that comma into the stack. So compare with the input grammar. No L comma is there, nothing is similar with this input grammar. Again we produce shift. Again we what? Do the action as shift. Again A is pushed into the stack. So the grammar, the stack will be dollar open bracket L comma open bracket L comma small letter A, and the input buffer become close bracket dollar. Then compare that elements in the stack with the grammar. Yes, A, small letter A is there. A is can be reduced by S. So in the place of A you can write S and give the action which is performed upon the stack. Don't forget to write the action. Okay, in the place of A you can write S. Again we compare the elements in the stack with the symbol with the grammar, right hand side of the grammar. There you can see L comma S. Yes, in the second production of the grammar L gives L comma S. So reduce L gives L comma S, that is the action to be performed. In the place of L comma S you can write L in the next step, capital letter L, because in the second production there you can see L gives L comma S bar S. So L comma S, in the place of L comma S you can write L, capital letter L, and write the input buffer as it is. Then compare with this stack element. If it is similar, if it gives any similarities with the right hand side of the grammar. No similarity. So just to perform shift action, shift or push the next symbol, that is first closing bracket into the stack. So what will happen in the next step? We get dollar open bracket L comma open bracket L close bracket. Yes, in the first production you can see S gives open bracket L close bracket. So that is the production. So you can replace that open bracket L close bracket by capital letter S. Okay, So reduce S gives open bracket L close bracket. You have to indicate the action as reduce S gives L. Okay, including the brackets. So in the place of open bracket L close bracket, you can simply write S, capital letter S, in the next step. Okay, and again we compare with this stack with the elements. So in the place of, in the second production, S is here, S is given. In the second production, L gives S. So in the place of S, you can write L. In the place of S, you can write L. So again a reduce action is performed. So reduce L gives L comma S. Sorry, reduce reduce yeah. Okay, just a prior one step below, that is, in this stack there is a dollar open bracket L comma open bracket L comma L close bracket. Okay, compare the elements in the stack with the grammar. If you find any similarities, replace that grammar or that element with the symbols with the production there. So here there is in the first there is one similarity, that is open bracket L close bracket. Replace that by S. So that is the action to be performed in the action column. What? Reduce S gives open bracket L close bracket. In that, in the place of open bracket L close bracket, replace this by S. Okay, okay, then again compare this stack with the grammar. What is similar? Yes, in the second production, L comma S, you can simply write L comma S. In the place of L comma S, you can write L. And don't forget to write the action, that is reduce L gives L comma S. Okay, and write, continue writing the input buffer as it is, in the input string as it is. Don't forget to skip, don't forget to write any symbols. Without any symbol, don't forget to skip any don't forget to write the elements in the stack as it is. Don't skip any step. Okay, then what happens in the last step? We get in the stack dollar open bracket, in the place of L comma S, you can simply write L. Okay, then open bracket L, there is no open bracket L in the grammar, that is right hand side of the grammar, no L. So which action to be performed? Shift action. So just push that or close bracket into this stack. Then what happens? What happens is in this stack there will be dollar open bracket L close bracket, and the input buffer there will be only dollar. The rest of the symbols are pushed into the stack. The action to be performed is you have to compare L with the grammar. Yes, in the first production you can understand, in the first production S gives open bracket L close bracket. So replace that by S. Okay, replace that, reduce. So you have to write the action as reduce S gives open bracket L close bracket. Yes, we reached the starting symbol of the grammar. That is our aim. That is the purpose of the shift reduce parsing, or the purpose of the bottom up parsing. So we have reached the start symbol. Start symbol is S. So in the stack there should be only what? Dollar and the start symbol S. That is, which is in the grammar, in this given grammar it is S. And input buffer, that is there will be only dollar, which indicates all the input strings are scanned and it is the end. Then we can write the accept as the action performed. Okay, you just practice it by yourself and write it down on